So we'll see the next question. Question number 16. Perimeters of a square and a rectangle are the same. If the rectangle is 12 centimeter by 10 centimeter, by what percentage area of the square will be more than that of the rectangle? So we'll see the working. So perimeter of a square and rectangle is same. So perimeter of a square is 4a and perimeter of a rectangle is, so here length of the rectangle is given as 12 centimeter and breadth is equal to 10 centimeter. So area of the rectangle, length into breadth, so 120 centimeter square. So perimeter of the rectangle, so here perimeter of the rectangle is equal to perimeter of the square. So 4a is equal to 44 and a is equal to 'so area of the square so we have got area of the rectangle as 120 centimeter square and area of a square is 121 centimeter square. So by what percentage is area of the square more than that of the area of the rectangle is got? So for this, when perimeters are same and when the length and breadth are two consecutive even numbers or two consecutive odd numbers, always length of the square will be 1 more than the length of the rectangle. So to find difference in percentage in their areas, so difference is 1 by length of the rectangle is 120 into 100. So which is equal to 0.83%. And answer for question number 16 is option A, 0.83%. And the shortcut here is, when the perimeter of square and rectangles are same and length and breadth of the rectangles are two consecutive even or odd numbers, area of the square will be 1 square unit more than the area of the rectangle. So we'll see the next question. Question number 17. Ratio of heights of two cylinders is 3:2 and their diameters are in the ratio 4:5. Find ratio of their volumes. So we'll see the working. So ratio of volumes of two cylinders are asked. So we'll have volume of first cylinder as pi r1 square h1 so for formulas we mention as units, and volume of second cylinder so ratio of heights is given as, ratio can also be written in quotient form 3:2 or 3/2, and ratios of diameters is given as equal to 4:5, so which is also equal to ratio of their radius. And to find ratio of their volumes, dividing both the volumes, So cancelling this pi. So we have R1 by R2 the whole square into H1 by H2. So we have got a ratio of radius is 4:5. So R square 4 into 4 by 5 into 5 and height is 3 by 2. Now simplifying this, 24 by 25. Our volume ratio is equal to 24:25. And answer for question number 17 is option E, 24:25. So to find ratio of volume, it is R1 square by R2 square into H1 by H2. So we'll see the next question. Question number 18. A cylinder, a hemisphere and a cone stand on the same base and have same heights. Find the ratio of their volumes. We have a cylinder, hemisphere and a cone. So to find volume of a cylinder, so it is pi r square h, and volume of a hemisphere so 2 by 3 pi r cube. So to find ratio of their volume, it is given that the cylinder, hemisphere and the cone stand on the same base and having same heights. So height of the cylinder, height of the hemisphere and height of the cone are all same. So here, as height of the hemisphere is also equal to the radius, we have got for all these figures the radius is equal to their heights. So now substituting h, r for h, we have cylinder volume as pi r cube, hemisphere volume as 2 by 3 pi r cube, and cone volume as 1 by 3 pi r cube. So now comparing these three volumes, so cancelling all these common factors, so we have 1:2 by 3:1 by 3, so which is equal to 3:2:1. So standing on the same base, the cylinder, hemisphere and cone volume will be in the ratio 3:2:1. And answer for question number 18 is option C, 3:2:1. And the workings are as follows.